we're going to have a quick review about the idea of the rejection region. Okay, so here our null hypothesis is the population parameter, which is population mean, mu is equal to mu0, versus its alternative hypothesis is equal to mu is larger than mu0. Okay, so we're gonna draw a plot. Its x-axis is the x bar, and its y-axis is the corresponding PDF, so which is the PDF of x bar. And we use the green curve to represent the distribution curve under the assumption of h0, that is mu is equal to mu0. And we use the red curve to represent the distribution curve under the assumption of alternative hypothesis, that is mu is larger than mu0. Okay, so here we're going to use a arbitrary point mu a to denote the mean of the alternative hypothesis. As long as mu a is larger than mu0, it's okay. All right, so the brief idea of the rejection region is to find a critical value c. Okay, and we let x bar is larger than c, which is this orange interval. Okay, so within this interval, and under the assumption of h0, so as you can see, the green curve, the green area, right? The green area is what we want. Okay, so the probability that x bar is larger than c, given the condition that h0 is true, is very small, right? So this is the corresponding green area. However, on the other hand, the probability that x is larger than c, given that the alternative hypothesis is true, which is the red shaded area, right, is large comparing to the green area. Okay, so in this case, it's more likely to happen under the assumption of HA rather than under the assumption of H0. Okay, so we say if the x bar that you observe is larger than C, or falls into this, the green area, okay, I'm gonna reject H0 and support HA. Okay, so that's the brief idea about rejection region. And probably you would ask me, okay, but how can I find such C? Okay, how can I find such C? Well, first of all, we need to know what is type 1 error and what is type 2 error. Okay, so first of all, we have to draw a table. Say, this is the truth, and this is my decision. Okay, so H0 is true, and H0 is false. Okay, so the column means the truth is H0 is true, and the truth is when H0 is false. Okay, and for the rows, it means we reject, our decision is to reject H0 or fail to reject H0. Okay? All right, so when the truth is H0 is true, but your decision is to reject H0, which means you have made a mistake, right? We're going to call this type 1 error. Okay? What about when H0 is false, but you fail to reject H0, which means you have made another mistake. Okay, so I'm gonna call this, I'm gonna call this type 2 error. Okay, if H0 is false and you reject H0, which means you have made correct decision, right? Also, when H0 is true, but you fail to reject H0, which also means you have made your correct decision. Okay, we call type 1 error as false positive, and we call type 2 error as false negative. For example, if you have enough evidence to reject the null hypothesis and support the alternative hypothesis, which means your alternative hypothesis is a positive to you, okay? Because you have decided to support the alternative hypothesis, so you have a positive here. But your decision might be correct, might be incorrect. If your decision is incorrect, then you have made a false positive decision. Okay, so this is called the type 1 error. And also for type 2 error, actually, if your decision is to fail to reject the null hypothesis, which means you do not support the alternative hypothesis, we say your decision is negative. Okay, but this decision can be incorrect, can be correct. If it's incorrect, then you have made the type 2 error. Okay, so we call false negative. All right, so let's go back to this curve. Okay, so if you're making a type 1 error, it means, first of all, you reject the null hypothesis, right? Because type 1 error is, this is type 1 error, okay? When H0 is true, but you reject it, okay? So reject HO, but HO is true, all right? Which means we're going to follow this green curve, okay? But you reject it, which means you fall into the rejection region, which is this area, okay? This area. So which means this area is the probability of making type 1 error. So what's type 2 error? Type 2 error is when H0 is false, but you fail to reject H0, okay? You fail to reject H0 when H0 is false. Okay, so when H0 is false, or you say you support HA, it's going to be the red curve, okay, the red curve. And then you fail to reject H0, which means you're within this interval, right? Because you did not fall into the rejection region. Okay, so which means I'm going to use the red color to represent. This is the type 2 error. Okay. And this green area is the type 1 error, the probability of making type 1 error. Okay. All right. So that's the type 1 error and the type 2 error in this graph. Okay. So we definitely do not want to make any of the errors. However, or intuitively, we should say we want, yep. So we would like to minimize type 1 error and type 2 error at the same time or together, but it's hard. So we have a strategy. Our strategy is to fix the level of the probability of making type 1 error and minimize the probability of making type 2 error. Okay, so although we want to minimize both errors at the same time, but it's hard. So our strategy is to fix the level of the probability of making type 1 error and then minimize the probability of making type 2 error. So let's go back to this plot here. Okay, so it means we need to fix this rejection region. Okay, and then we'd like to minimize the left-hand side, which is the area of the type 2 error. Okay, so how can we do this? We're gonna set the probability that you reject the null hypothesis when the null hypothesis is true. So this is the type 1 error, right? Reject H0. And we're going to set this probability, type 1 error. Okay? And we're going to set this to be a fixed level. Say, I'm going to use this, use alpha to denote this. Okay? So this is equal to alpha. And I'm going to let this alpha to be very small, say 5%. Actually, the exact value of this alpha is pretty subjective. Some people would like to have alpha is equal to like 1%, but sometimes for some of the people, like 10% is also acceptable. Okay, so here, if I set this alpha to be 5%, which means 1 minus alpha in under this, the green curve is equal to 95%. Okay, so because we have discussed that if you reject the null hypothesis, we need to let x bar is larger than this c. Given the condition that h0 is true, it means mu is equal to mu0. So this is my alpha. All right, so we can use this idea to fix this alpha, and then we can find this critical value c.